Hi everybody, it's Della from The Beauty of Play. We have been doing our chemistry block and I haven't showed you our resources yet, so I'm going to do that today. So if you've been following along, you know that we are approaching this block through the four ancient elements: earth, air, water, and fire. And if you would like to see more on that, I talk about that during our chalkboard drawing video, which you can see on YouTube. And I'm going to also try to write a blog post about that that you can find on my site, thebeautyofplay.com. And just a note, I am trying to write this chemistry block as we move through it so that the guide will be available to you soon after. It does take some time with editing, but if you are viewing this video well after the block, you should be able to find that guide in my shop at thebeautyofplay.com/shop. Okay, on to the books. So two of the books that I'm going to start out with don't really have much to do with chemistry at all, but we are opening our chemistry subunits, fire, earth, air, and water, with a watercolor, wet on wet watercolor, and a Native American story. And so I am using Color Dynamics as inspiration for our wet on wet and Keepers of the Night. At the time that we've done this video, we've done 3 of the 4 wet on wets that we are going to do. I really enjoy Color Dynamics by Angela Lloyd. She also has form drawing, but it goes through first individual colors and all kinds of various skill level that you can see here. We're going to definitely be using the individual and 1 or 2 colors for our themes for earth, air, fire, and water, and we are often looking through this book to give us ideas as we go along. Keepers of the Night, and there are 2 other books of this, Keepers of the Earth and Keepers of the Animals, is a wonderful, it's a full curricula for younger children, which we have used in my Native American guide, which is available in my shop. That's a free guide. Anything purchased for that 100%, there are no profits. That goes to Native American causes. So if you purchase my Native American guide, all of that gets given to Native causes. So the beginning of each of these has a story in the front, and then it also usually has a discussion right after the story. I am choosing 4 of the stories that are appropriate to earth, air, water, and fire to teach, and then we're going over it. The first one that we did for water was the story related to water, and then went into discussion for the water cycle, which was just a perfect segue into water, which was the first segment that we did. Really enjoyed this book. Okay, the next set of books are the books that I'm using for source book or reading material. I haven't used a whole lot of this, but I really love Building Foundations of Scientific Understanding by Bernard Nebel. He has an elementary series, 3 volumes, I believe, and then a middle school book, and they are just really excellent. They definitely follow discover and learn kind of philosophy that happens, critical thinking, that's the Waldorf style, like discover the concept and learn about it rather than someone just straight out beginning from the beginning telling you this is how it works. You get to discover that concept. I love how he approaches the middle school. There's a lot of critical thinking in here. My only complaint is that it becomes less hands-on through this than the early elementary, but it's not a huge complaint. And the level of critical thinking that's involved, I really enjoy from this series. Okay, the experiments that we are doing come from two sources: Chemistry the Waldorf Way, grades 7 through 8, and we're not really doing the organic chemistry so much. We are doing what would be considered a 7th grade block, which is inorganic chemistry. And this book has both the 7th grade and the 8th grade block. We're working on the 7th grade, and the guide will be mostly in organic chemistry, not so much organic chemistry. Love the experiments in this book, and this definitely has this set up in a way that you would often find happening in Waldorf schools. And I say it that way because Waldorf is a pedagogy, it's not a curricula, and so you could develop several different kinds of curricula that did things in different ways that was still age appropriate and still adhere to the Waldorf pedagogy. My understanding is this is the type of thing that you would find in most Waldorf schools. Like so many other things that we do, I took a lot of inspiration from this, but we did not follow this in several different ways. One is that 7th grade chemistry usually starts with combustion. We did not do that. When I went through and looked at the combustion, I just felt like there was a lot of information that was needed before you got to that point in combustion. And so we started with water. And it also has these segmented in the same way that I was talking about earlier: earth, air, fire, and water. So it was really easy for me to pull from the water sections. We also did not do all of these exercises. I am picking and choosing the ones that I like. The one thing that I really enjoy about this book is that it does go through and talk about the Waldorf approach to sciences, in particular chemistry. It talks about how it's organized. It talks about leading the child into the discovery and clear and focused observations and then recapitulation. It does go over each of the sections that it's talking about. So it goes over a little bit of combustion. It goes over the water cycle. It goes over what you're looking at in the 7th grader in a chemistry block. Some of like what's happening for a 7th grader and how this is appropriate to 7th grade. It also goes over how to do many of the exercises and where to source different material for the exercises that they are talking about. The downfall to this book is that it doesn't give any of the science. It doesn't talk about the chemistry behind what you're saying. And my guide definitely will. It will basically give you a narration after every demonstration and what that demonstration is illustrating. This book does not do that. The downside to my guide, if you want to do it specifically in a Waldorf way without any deviation, is that I will not be doing every single one of the exercises in this book. So that is the downfall for this, is that I feel like it just doesn't give an explanation. Often it does talk about what observations we need to be sure to make or the chemical characteristic that we're working through, but no science background on how that works. And he's very upfront about this in beginning and says that you will have to look for other books for those concepts. But as a homeschool parent, especially if science isn't something that you excel in, I feel like that's too much to ask. I'm going to do that for you, but also I'm going to give you other books in case you want to build your own that do that for you. Another resource that we are looking at is the Usborne Illustrated Dictionary of Chemistry. This suggestion was from Kimberly from Sunshine and Rubies. If you saw the workshop that we did on this, she talks about this book and how the beginning of the book was basically the concepts covered in her child's first college chemistry course, basic college chemistry course. But this goes over the basic chemical concepts for inorganic chemistry, which is nice to have. It also goes over the periodic table in the back. The downfall with this book is if you don't know in science, we're constantly learning new things, finding out information, expanding on what we know, and sometimes that alters our view of things a little more and it shifts things. For instance, in the mushroom world, we now have DNA analysis, and this DNA analysis has allowed us to see that some species that we thought were related to other species really aren't. And it allows us to classify mushrooms more appropriately. So a lot of mushrooms are getting new names and being placed in new places. This also happened with the monocot and the dicot in botany. There was a change where we realized that the dichotomy between them was more having to do with eudicots and monocots. And so now when we study botany, we study unicots and monocots. Dicots are included in the eudicots, but sometimes that trips people up quite a bit. And it's just the nature of science. We learn new things. It opens us up to being able to see that information more clearly, and things get reorganized or relabeled. And that happened with the periodic chart. When I went to school in college, the periodic groups skipped over the transitional metals, and they went from this side of the periodic table over to this side of the periodic table. And you will see a lot of books, including this one, where that has happened. That has made the study of the periodic table a little challenging, because are we doing it by groups or are we studying it by group blocks? So in a periodic table, when we go down the left side, all of the row headers are periods. When we go across the top, each of the columns is labeled as a group, so that changes our other groups. So be aware of that if you are looking at the periodic table. Obviously, it doesn't change the chemicals or their properties, but it does help clarify the groups that we're talking about, and it doesn't leave out the transitional metals. When we're going through the guide and studying the periodic table, you're just going to have to be careful, depending on what book you are referencing, that the group after group 2 is the group that you're actually speaking about. Because, for instance, this group 13 here, I think, is actually group 12 now. So just be aware of that and the changes in the periodic table, so that when you're studying the periodic table, you can give the most accurate information for that. So this is Usborne's Dictionary of Chemistry. The other book that we are using is Super Simple Chemistry. This is basically catching the gaps for chemistry that I'm not seeing in the other places that I want reading about, such as combustion. I didn't find a lot on combustion in the other books. This has 1 page of combustion. There's actually not a lot of information on combustion. And so it's filling in that for that. I don't feel like this is written in the most interconnected way, so we can understand the processes that are happening and how they're relating to each other, and then also how they're relating to real life. But one of the things that it does have that I really appreciate are a number of graphs. In middle school, this is the time that we need to be studying these graphs and having an understanding and being able to interpret what these graphs mean. And this book is full of graphs. It also has various labs and stuff, but what I have found in the other books, particularly biology, is that these labs are not written with enough specificity for you to repeat it. But it is helpful just to look through it and discuss the graphs and what you're finding. It also has a lot more math in it, which I love math, and I love that it's practical math. Also, this one has periodic table. I do not know. This is by the Smithsonian DK, and I think it's a more recent book. Other sources that I'm using are the American Chemical Society's middleschoolchemistry.com, which is basically a free chemistry curriculum available online. I feel like it's really well done. It has reading material that we are using, and then I am pulling several different exercises, particularly from water, and some for the salts block from middleschoolchemistry.com. So you can check that out for your information, and also for some really good word problems at the end of these chapters. There's Chemistry Made Simple. I had originally thought that we would read this book. The equivalent to this for Physics Made Simple, is simple enough that it could be read for a middle school level. But this is a little more complex than what I was looking for a middle school level. And I originally thought we would be reading some of this, but the more of the material that I read, the more that for an introduction to chemistry, I just felt that it was not appropriate for a middle school level. It is really appropriate for you if you want to spend some time learning chemical concepts that have to do with the unit and demonstrations that you are doing. This is a really good book, and it also has really good word problems having to do with what it is discussing at the end of a chapter. It has a word problem set at the back. And this is getting an honorable mention, even though I didn't end up using this at all. This was the same thing. I got this for the chemistry reading. When I got into it, I realized that this really is more high school, maybe even moves into a college level, and it just wasn't appropriate for middle school. It could be appropriate for you if you want to learn more, but I ended up not using this at all. Another book that we are using some to fill in the gaps is the Kingfisher Science Encyclopedia. This doesn't just include chemistry. This has a number of all of the earth sciences, including living things, human biology, chemicals and elements, materials technology, light and energy, forces and movement, planet Earth, electricity, time and space, conservation and the environment. I am using it again for things to fill in the gaps, for reading and things that I want her to know but are not available in the reading that we're doing. This is helping to fill in the gaps for those. On to supplementary books. There are a few books that we are reading. This is The Elements, A Visual Exploration of Every Known Atom in the Universe by Theodore Gray. I really wish it had more information on the periodic table. It does have the periodic table. It does have information, which we read regarding the periodic table. It does not have the groups and going up over each group individually, but I will show you how we accommodated for that. However, it does have a page about every single element that they've had so far, which is very nice. But what we have done is purchased the card set that goes along with that. So this is the card set, and you can see I've used a number of tabs from our tabbing to mark them as we go along and study that group of elements. Now, in the beginning, we started out studying them by chemical group block. So the alkaline metals, the alkaline earth metals, and then these groups are like 3 through 12, I believe. Transitional metals, we studied those all together, not individual groups for how the periodic table is arranged now. So as we go through, we will find out what the alkaline metals are. We will pull all the cards for the alkaline metals. On the backs of these cards, it has a wide variety of information from the atomic weight, the density, the melting and boiling points, the electron formation down here. It goes through each of the energy shells and each orbital included in those energy shells and shows you how it distributes the electrons. It also gives a little information about it and what percentage is found in the Earth's crust. I'm going to pull a more complex one. This is from the transitional metals. It is seaborgium. I probably have pronounced that wrong, but you can see all of the information that it has here. It does give the half-life if it is radioactive. It has the symbol at the top if it's radioactive. This one happens to be radioactive, but then you can also see here that it gives how it fills its electron shell and what sequence it fills. First the first, second, third, fourth, and fifth energy shell, and then part of the sixth energy shell, and then it skips and fills the s orbital of the seventh energy shell. It gives that information. Going through and looking at these groups allows us to see the similarities and differences in the group, and because these are cards, we're able to sort them. We are making our own chemical block cards. I'll pull those here, but not every card, because that would be quite a lot. And we're putting the information at the bottom so that we can sort and move through these. But these cards and these are kind of different purposes. I've also made, which will be included in the guide, is a series of Lewis electron figure diagrams that can be filled in according to the orbital for that. And we're mostly doing the top half of the periodic table for manageability, both in electron configuration and how they react to one another, and then also because it would be too much to do every element unless your child is very much into the periodic table, and then I say go for it. Okay. Other books that could be used that we're not really using, these are the Bascher Books, the periodic table, and then they also have one on chemistry. These are really cute books. This goes over the periodic table. These also, I think, are organized in the old groups. See, this is chapter 5 on the carbon elements, group 4, and that's no longer a group 4, but still you can, you know, just talk about those. Another book you might be interested in that we also are not using is this book that was given to me by a friend, Theo Gray. I think he is the same one, yes, that author for the elements, and this is called Mad Science, and it just goes through different chemical reactions that give a lot of ooh and ah, things that you don't see in day-to-day life very often, and it's just a really interesting book. It does have many labs that you could repeat if you so desired, that I don't think many of them are included in what we're doing, but also a very interesting chemistry book. Additional supplemental material. We're not reading this book. We have chosen additional books, The Story of Science, but there are several really cool chemistry books that you could choose from. I purchased this one, What Einstein Told His Cook, that basically is the science behind cooking. It's really interesting. Its format is question and answer, and it's kind of interesting. There are several of these, including Napoleon's Buttons. If you're more inclined to history, that works really well, or if you are studying history, that's a really good way to combine the two of those. Additional books are Genie in a Bottle and also Disappearing Spoon. These would work well as like read-alouds or read-alongs as you're going through this unit. I would also suggest, which we haven't done up to this point, but biographies of chemists. There's really good books about all kinds. Maria Curie, Michael Faraday. Like, there's so many really good books. I think there's a series of books, or maybe just one book, of all of the candle exercises that Michael Faraday, was it Michael Faraday that did the candle exercises? Anyway, there are loads of read-along books that you could choose based upon what you're studying or your child's interest or your child's reading ability. We are using Joy Hakim's The Story of Science series. The first one is Aristotle Leads the Way. John Hopkins has a whole study guide, really thick. I mean, these are amazing books. 3 series of study guides that go along with these that can be purchased, I think, or I'm not sure, there might be free. But these are basically the story of science that goes through just a history of science. And I really enjoy her writing style, the storytelling narrative style through history. It starts with ancient Greece and it works its way through. It covers physics, math, and chemistry. It does not cover the biological sciences, which I was really surprised. I have supplemented that in various ways with other things that we've used, but this does cover all 3 of those: math, physics, and chemistry. And there are 3 books to this series: Ancient Greek with Aristotle Leads the Way. Newton at the Center is the second book. These are also Smithsonian books, so you know they're high quality. And then the third book, Einstein Adds a New Dimension, and this goes through Einstein to the current age whenever it was published in 2007. So I'm sure we have a lot missing here, but are some of the books we're using and some of the other books that are optional. I hope you enjoyed the video. Look out for the chemistry guide on this blog. It'll take a little while to go through the editing process, but it'll be out soon. And until next time, happy homeschooling.